going to introduce something that is called your division statement. And what your division statement is, that idea of what we wrote before and what we're going to label these things a little bit differently. Whatever polynomial you have is going to be equal to what you're dividing by, what your answer is, which is your quotient, plus your remainder. And I find this pretty easy to remember because I see DQ and I love ice cream. Went there twice over spring break. It was wonderful. So polynomials equals Dairy Queen plus remainder. And we did this when we write our division statement. So when we had no remainder, this was our polynomial. We divided by x plus 1. We got a quotient of 2x squared. And there was no remainder, so there was 0 here in the end. You could do it when we did numbers, and we did that at the beginning here. When we had this first example of 2,748 divided by 13. This is what we started with, our polynomial. We divided by 13. We got 211 as our answer, and then our remainder was plus 5. So we get this form of the division statement. And so when we go to example 2 now, it says divide 3x to the 4 minus x cubed plus 3x minus 20 by x plus 2, also to write the division statement. And in this example, we introduce another thing that comes up with polynomials that doesn't come up with numbers, right? In numbers, you never have this problem, right? No one ever decides to write 107 like this. Oh, I'm just not going to write the 0 because 0 means nothing. If I leave enough space there, you'll just know that that means 107, right? Or, right? And this would be, well, that's 1,007. That's not confusing at all if I don't write the zeros. We write the zeros because they're important. They hold a place for our number. But in polynomials, so when we set up our long division for this one, we're dividing by x plus 2. It's already in the right order, so that's good because that's the first thing that we learned from example 1, that we have to write it in order. So 3x to the 4 minus x cubed, but there is no x squareds. So when we're writing that, we don't have to write anything when it's not there. But for long division, we're going to go plus 0x squared, so that's there, plus 3x minus 20. So we're going to put a 0 in there as a placeholder. We do that naturally with numbers. And since everything works out nicely in columns here, when something's missing, we'll put a plus 0 in there. So if there's a constant missing, we'll put a plus 0. If there's two things missing, we're going to put plus zeros in for each of them. And now we go through the same process as we did before. Our biggest one from left to right is 3x to the 4. What would I have to multiply an x plus 2 by to get 3x to the 4? It would be 3x cubed, so I write that over my x cubed column. 3x cubed times x plus 2 gives me 3x to the 4 plus 6x cubed. When I subtract, sure enough, this is 0. Negative x minus negative 6, or minus 6, will give me negative 7x cubed. Bring everything else down, which includes that 0. My next value, now I need to get a minus 7x cubed. What would I have to multiply an x plus 2 by to get a negative 7x cubed? A negative 7x squared. So we get an x squared even though we didn't have an x squared in our original function. And so the column is there, which is nice. And then when I multiply negative 7x squared times x plus 2, I get negative 7x cubed minus 14x squared. And when I go to subtract, well, this goes to 0, but here I get plus 14x squared plus 3x minus 20. And now my largest value is 14x squared. So I would have to multiply by a 14x to get a 14x squared. Our numbers are getting bigger here. Again, remember to put brackets around and subtract. So when I subtract, I get 0 minus 25x minus 20. Switch to red. Now my biggest term is minus 25x. I would have to multiply by a negative 25 to get that. Negative 25x minus 50. Again, subtract. This will be 0. Negative 20 minus a negative 50 will be plus 30, and that's our remainder. So after we've done our long division, now we can write our division statement. So our division statement that's where we're going to do the Dairy Queen thing. Should really get sponsorships from them. Be a perfect advertisement before the 5 views on this video that I will get. So our division statement is our polynomial is a divisor times our quotient plus the remainder. Our polynomial that we started with was 3x to the 4 minus x cubed. You don't have to write the 0x squared. You can, if you want to, plus 3x minus 20. That's our polynomial. We divided by x plus 2. So that x plus 2, that's your divisor. The answer that we got, if we go up to the top here, was 3x cubed minus 7x squared plus 14x minus 25. Oh, I forgot it already. 3 minus 7 plus 14 minus 25. That's your quotient. Quotient is the answer that you get when dividing. And then we had a remainder of plus 30. That's our remainder. So this is our division statement. Now, sometimes what students like to do, because it is long to write out the whole division statement, sometimes what students like to do is at the top of their question they say, let P of x equal all of that. So that when they go to their division statement, instead of having to write that first one all again, they can just write P of x equals. That's a little bit shorter, but you do have to define it. You have to say somewhere at the beginning of your question that P of x is equal to that initial part so that it can be shorter for you later. Okay, now you can do 3b to add the 0 and question number 7.